My pleasure to welcome all of you to the fifth webinar of the series Sustainable Transport and Livability. Today, again, we have a very esteemed speaker, an established personality in transportation research, Professor Meng Li from Tsinghua University in Beijing, China. I'll first do a brief and small introduction about this webinar series and the host, and then I'll invite Professor Mangli for his presentation to start. Let me first share my screen quickly. Hemante, can you confirm if you can see?
Yes, yes, I can see.
So, as I mentioned, today's fifth webinar is on resilient traffic management and control under emergency events, and this will be delivered by Professor Mangli from Tsinghua University. Um, this is jointly organized by the WCTRS Special Interest Group F4, which is on sustainable transport and livability, in association and together with the journal on the same name, Sustainable Transport and Livability, which is published by Elsevier. And of course, our IST lab is the host. The purpose is to foster knowledge exchange and propel the discourse on the topics that are related to understanding causality between sustainable transport and livability. We have been doing one webinar every 2 months, and the potential speakers includes eminent researchers through invitation and selected authors of papers that have been published in TSTN journal. The first webinar we had by Professor Aruna Shivkumar from Imperial College on 7th March. And second webinar on the concept of 15-minute city by Professor Ahmad Al Kennedy on 2nd May. Likewise, we had 7th June the third webinar on quality of life and walkability beyond accessibility by Professor Kazuki Nakamura, as well as another presentation during the same session by Professor Pushpa Chaudhary from IIT Roorkee on electric bus services in Kathmandu. And the last webinar, the fourth one, was delivered by Professor Roger Wickerman from University of Kent and Imperial College London, about rethinking accessibility in a post-pandemic and net zero world. I'll present our today's speaker towards the end. Of my introduction. Just a glimpse about the WCTRS SIG F4. This is chaired by myself and co-chaired by Professor Kazuki Nakamura from Nijo University in Japan. And as I said, it basically tries to focus on the linkages of sustainable transport and livability. These are all the SIG members. If somebody is interested in this special interest group, feel free to contact me. The Sustainable Transport and Livability Journal, which is published by Taylor and Francis Group. It's an open access journal launched on 7th November 2023. It's currently offering, full fee waiver and open access fee waiver to all authors till end of this year. This is the editorial board, and I'm happy to say that Professor Mangley is also one of the associate editors of the journal, and we have editorial board members from all across the world. These are all in the aims and scope of this journal. It's looking at these linkages of transport to, for example, dimensions of well-being, or how transport can make society and individuals healthier and happier, how it impacts quality of life, safety, accessibility, disaster resiliency, and so on. I also just want to, before conclude, talk about this first World Symposium on Sustainable Transport and Livability, WSSSTL, which will be held next year, June 20th, 25th to 27th at ISC Bangalore in India, in the city Bangalore. And then it will, it's the first symposium in the series. It's a biennial series, so it will subsequently rotate once every 2 years in across the world, in some part of the world. And again, the idea is to bring this community together of researchers and practitioners in mobility across the world and share the knowledge and evidences of these linkages that we're trying to investigate. It's jointly organized by SIGF4 and the Department of Civil Engineering of Ministry of Science, who is celebrating its 75 years. This is the website of the symposium, WSSTL 2025. Please visit the website. The call for paper is currently open till the end of November this year. And all the papers that would get accepted for symposium would also get published in the journal Sustainable Transport and Livability of Taylor Francis. To introduce our speaker today, Professor Mangi. He is a tenured professor in the Department of Civil Engineering at Tsinghua University, Beijing, China, and also the Dean of Tsinghua Mercedes Joint Institute for Sustainable Mobility. He graduated with a bachelor's degree at Tsinghua University and obtained MS and PhD degrees from University of California, Berkeley, and now Nagoya University, respectively. Yes, the important thing is also the associate editor of our journal TSTL, published by TNF, and he is the topic area manager within WCTRS for the topic area H, which focuses on developing countries. So, with this short introduction, it's my pleasure to invite Professor Mangli to start his presentation. Over to you, Professor Mangli. You can share your screen.
Thank you, Ashish. Let me share my screen. You can see it, right?
Yes, we can see your screen. Slides.
Slide.
Yeah, perfect. Please go ahead.
Okay. Thank you, Ashish, for the kind introduction and also for the invitation. It's my great honor to be here to give a talk for the web series under the subject of sustainable transport and livability. How to make it? Hold on. Oh, okay.
You
where
can
is
just minimize the video if you. Yeah.
Okay. So yeah, when Shish sent the invitation, I was thinking what to talk under the subject of sustainable transport. So at the time, I'm actually leading a project, international collaboration research project under this subject about the resilient traffic management. So I think this is a good topic to talk about. But before I start to talk about this, the project, actually, I would say this is an ongoing effort. So some of the result is still not in the perfect final form. So, but this is the first-hand result I would like to share with all the audience. So for the topic, I would say I will just trying to quickly talk about the three parts. Hopefully in about 30 minutes, roughly. So I will start with the background quickly. Actually, as everybody know, this is coming. The urban natural disaster is coming much more frequent than before. The hurricane coming to China is much more frequent than before. And also I think to India and also to US, it's the same. And right now there is still a few hurricanes the worldwide right now. So I would say the frequency is going up, and also we see the more of the economic loss due to the natural disaster. So I'm showing a figure to the left. This is for 10 years, starting from 2012 to 2021. Is trying to compare different country, the frequency and also economic loss from the natural disaster. And unfortunately, China has the highest frequency of the natural disaster in the world. And we are also number 2 in the economic loss due to those disasters. So this is a very hot topic nowadays in China, and also not only in the community of transportation, but also for the city planning and city management. And here to the right, I'm showing a figure. This is from 2022. The natural disaster caused a total 112 million people to be affected. This is in China, so this is really a huge information. And for the natural disasters, this make a huge impact to transportation. is showing not only for the crowd retention, also we got the information, the number over 50% of casualties were due to the failure to evacuate and rescue in time. So this is really, there's a big gap for transportation to improve during the natural disasters. So this is why we have this topic. But when we trying to study this topic, this is a quite complicated topic. One comparing with the normal situation for the traffic, either management or planning. So when we talk about the complex transportation system under emergencies, we talk of three aspects. From the person or the passengers, we can see the high randomness in driver, the path selection or the route selection. So for the system, it's difficult to make to predict what people make the decision. So this is a pretty tough one for the traffic system manager to make the decision. Secondly, when we look at the network, the traffic network is also very difficult to make accurate prediction in the abnormal situation because the sudden changes of the road condition, either flooding or maybe electricity and so on. So this is a sudden change, not a very timely smooth for the traffic condition. So this is a very challenging topic. The other one is with the person random decision, also the network condition, which is abnormal, it's very difficult to have the group collaboration during these emergencies. So this is even more challenging when we see the individual navigation, trying to have people to rescue in this situation. So this is a very challenging topic at the system or the mayor or the decision maker, you need to improve the traffic management capabilities under emergency. So this is the research goal we have, and also the challenges we have. And this is as I say, the collaboration project. We call it in China is a national key research and development program. The topic of this project is multimodal traffic collaborative evacuation based on smart navigation. So basically, there are three institutes joined the project, led by Tsinghua University and also the HKU, or Hong Kong University. And the other one is AMAP. Actually, for Chinese, while AMAP is very popular, is the number one navigator in China. Maybe for the international scholars, it's not so popular. But here I'm showing some data about AMAP. This is really having a huge amount of information, the traffic information, which is very helpful for traffic management. So here is showing some of the data. While it has the data coverage for 95% of expressway and urban road network in China, and also it has 20 billion kilometers traveled information from the vehicles. And also it has collaboration with more than 200 cities, direct cooperation. So it has direct information from traffic police. And also daily it has more than 1.9 million incidents report from this AMAP software. So it has huge amount of data which can help us to learn how to do the traffic management during the evacuation, during the emergency situation. So for the next few slides, I'm showing some of the data capability for the AMAP. This is the one showing overall the trip information, the trip data it has. So basically, it has a good coverage for the whole China. Now it has also coverage for international, for the whole world. But it focus more on the China. This is a map of China, and it has data coverage almost everywhere in China. This is showing the map from Beijing. This is showing the real time at the time when the video is recorded. It has all the data from the navigator, all the vehicles running on the street. It's about more than 50% of users right now are using AMAP. So it's showing each dot on the road, actually the moving road. This is showing the vehicle is using the navigator. It's showing the on the freeway and on the expressway of the Beijing, and also on the local road you can also see on the other side. This is showing the data collection capability for the trip data. And this is showing also not only the trip data, but also it has the incident information for the abnormal situation. So this is also use the example of Beijing. This is you can see this is a map of Beijing. This is showing each dot has the information, and also it has the report of the information for the incident. Well, for example, here this is one showing it's an accident. Well, for this kind of incident information, there are basically two sources for those data. One, as you can see, the pie chart to the left, the blue one is showing from the data calculation. It calculates, and there is some incident happen, which is when compared with the normal traffic is different. So it's showing blue. For the pink color, this is the user report. Basically, it's showing the users can report from the apps. They can report what happened or what you can see from the road. And the other part is also from it's a green color, which is not that much, but it's from traffic police. It's reported information to the AMAP, so we can have quite a good coverage for the traffic incident data, which is happening on the road. And more than that, this is showing the OD information. This is the same using the example of Beijing. This is showing the trip. You can see the line is the trip. One is making the trip plan. You can see the O and D showing on the graph, but it will not show the name or the cell phone number, whatever the privacy information is all marked. But this is showing the trip information. This is very valuable for the OD information when we plan, or even during the emergency, if we want to know where those people or what vehicles want to go, this OD information is very valuable. And here is showing more of the OD data. This is showing the commuting trips. When you're trying to have to the left, it's an inter-region. You can see the inside of this region, which is called Wangjing in Beijing area. And this is going into Wangjing, and the yellow color is showing the going out of the region. That's OD. And to the right, this is inner region. This is in the Wangjing area. We can see all the OD the commuting trips. So this is very valuable for our information. So this is showing what data it has from the AMAP we can use for our research program. And also here is showing the data source, not only for like the Google, it has navigator information, but for AMAP, it has much more than the navigator. It's showing here the data source, including 300,000 apps. Actually, it's those apps providing location-based service. For example, the Alipay, and also for the shopping, and also for the grocery, and for the short video platform and so on. When it provides a location-based service, it also provides data to AMAP. So from there, we can have more of the OD information than only the navigator information. So this is showing where it has the data from. So with that, I can talk about some of the research effort we have for now. So the second part is the ongoing research results we have by now. And later on, we're going to talk about summary and the future plan. So this is the whole research plan we have for the whole project. And for there are four parts mainly. And the first one is about the route choice under emergency. As I said, for passengers or for person, when they make a random choice, how are we going to learn from those choices? We can understand their choices. So the first one, we established the route choice model under emergency. The second one in the middle, as I say, is about the traffic network, the prediction of the traffic status. So during the abnormal situation, so we have a few different models, the neural control model and the wavelet and the Fourier. Later, we're going to talk about the models and results. And the third part is about the evacuation bus dispatch. Basically, when there is an incident or accident for the subway system or some of the metro station, And then with huge amount of passengers had trouble there, we can use different mode. We can use bus or taxi to do the evacuation, but we can have the dispatch model. So for this part, considering the time limitation, I won't talk about this part, but I will talk about the other three. So the last one, this is also the ongoing, it's about the dynamic robust optimization for the group navigation. When we understand the people's choice and also the network prediction, we can make a navigation evacuation decision for the decision maker. So this is overall the architecture or the plan for our project. So I will start talk about one by one. Uh, just this is the first one. It's about rule choice model in emergency evacuation scenario. This is basically talk about the storyline. During the rain or when it started to rain, traveler or driver started to trying to find the best route in the navigator. And then, so this is showing from the origin, the number one. And then number two is when you see some of the flooding in some area and then it decided to comply because it has very limited information. It would like to comply with the rules suggested by the navigator. And when the vehicle is approaching to the next step, and then it see is so much congestion, which is abnormal. So some drivers decide to deviate from the original path, so make his or her own decisions. So basically, we want to understand how the drivers make a decision during the whole route. So this is based on all the data we have. So before we start the study, we trying to understand the research gap. And for the existing discrete choice model is more for the normal situation, not for emergency scenario. And for the machine learning methods, there are so many things is under the black box. So we still want to understand more with the discrete choice model for the emergency situation. So this is basically the bi-level dynamic recursive model we set up. And then we later on we can do the parameter estimation based on the model. So this is the setup for the bi-level dynamic recursive model. And they will assume each passenger or each driver at the time will make the decision for next step. One is comply with the route suggested by the navigator. The other one is deviate from the original one. So this is basically two part of a decision. The upper level is whether the driver is strictly in compliance with the navigation recommended route. The second one is the driver will make their own decision. So this is a bi-level decision. And the upper level decision parameter is related to the environmental information, say the rain and also all the congestion information. The lower level is about the network factors. So this is how we set up. And this is showing the upper level. We have the utility decomposition from basically two groups. Group one is the environmental factors about the weather, the overall weather, not the specific flooding area, but it's overall, it's a rain, the little rain or heavy rain. And the A2 group is for the navigation related factors about congestions. It's about the accidents on the road, or it's about for this trip, the length of the trip and so on. So this is basically two group for the upper level decision when it makes the whole route the decision. And for the lower level decisions, there are also two group of factors. The B1 group, it has the static factors about the length of the routes and how many turns it has, and also the route grade, either expressway or the urban local street. The group B2 is the dynamic factor, is the congestions, it's accident happening. So basically, we have the two group of the parameters for this, the lower level decision. We set up the multi-logic model for this with all the data. So this is basically how we got the utility function, and then we trying to estimate all the logic random parameters from this. And this is the value function we have, considering both of the rule selection utility and also the utility is how we utilize the navigation. And this is how we got the parameter estimation, basically using the most likelihood method. And then with the first order gradient, we can have the elimination for the differential factor parameters. So we can have the final parameter estimation from this. And we first start to use the is the Surox 4. This is a quite popular network we have. And basically, we trying to estimate the upper level parameter and also the lower level parameter. And with that, we see from the Source 4 network and with the estimation of all the parameters, we can see this is a good and unbiased estimation. So this is give us the confidence we can use the bi-level model to do the driver route choice model. And then we started to use the real data from the AMAP. This is using the Guangzhou, which is the southern part of China, the city of Guangzhou, and a lot of rains actually for the area. And we picked the middle of the old town, Canton. This is an area with a huge amount of traffic and also complex road network and heavy traffic for this situation, and also a lot of rains. So with that, we have the data for about half a month data from the March to April, about a month's data. The data we have the incident data, and also we have the congestion and so on. We also have the speed information for this part of the road network, and also the navigation data. This is very valuable. Well, before we can also have the trajectory information for all the users, but now we have what route we suggest to the user. So we know the decision of the user, the driver. So this is very valuable for our dealer choice model. And this is how we set up the information. This is to the left is the navigation information. It's how the navigation give the routes and also the link ID of the routes. To the right is the actual trajectory. Actually, the driver make the decision which route it goes. So we can compare and make to see the difference. And also showing the coverage. This is to the left is showing the road grade. It's a main road and the secondary road. The main road is more about the arterials and so on. And expressway and also the branchway. It's a different number of the road links. And also this one is showing the link length, the distribution of the link length. And also to the right, it's the incident information. So majorly it's accidents, and also there are some work zones and congestions, and also flooding and closure, road closure, and so on. So this is the data we basically have. And this is the model we set up for the upper level attributes, including two groups, as I said earlier, including the environmental factors, the weather, the overall accident, and the congestions. So A2 group, we have the navigation related factors, the distance travel from O to D, and also the work on the way and the flooding. And for the lower level decisions, basically you have the static network information and also dynamic network information. So what we have, we're trying to see the real world. We set up different models here to include a different group of the parameters. So we see which group of factors really make the difference. And we see this is the preliminary results we have for this. So the bi-level model and including the dynamic characteristics of the road network significantly improve estimation performance. So the best, we have all the group of factors, so all play the best. And among them, environmental factors group A1 and dynamic network factor B2 significantly influence the performance, which are the most important factors we have. And here is showing how the behavior, really how the driver make the behavior. We have some observations. So if there are more rain and congestions, there are higher compliance rate. And when you see the road flooding factors not significant, well, when drivers see the road flooding, it seems not really making different decisions quite often, because the limited information he can has, he doesn't know where and how much of the flooding on the road network. And the shorter distance with the lower compliance, and for the longer distance, it has higher one, definitely. And low compliance when navigation route include accident and congestions. And then here we also see for the left-hand factors and accidents, congestion also significant for the upper level decisions, and road flooding make driver avoiding decisively, but not being a significant factor. So this is some observation we have. And here is also showing for different type of rain. So there are five levels for no rain, light rain, moderate rain, heavy rain, and a rainstorm. We see for most of rains, this is how the driver make the decisions and additional utility from the navigator. So for most of the rains, the driver has no major difference for the navigation compliance rate. But also, we only see the heavy rain, and particularly for the rainstorm, for the very heavy ones, we see there's a significant difference, one for the compliance rate. For the starting from moderate rain and light rain and no rain, there's no major difference. This is mainly because maybe in Canton there are so many rains in the daily travel. And here is showing the influence of the navigation related factors. We can see the navigation routes with congestions, accidents, and so on make a lower compliance rate by drivers. And here is some observation we have and some conclusion from the first part of study. So basically, by constructing the bi-level driver route choice model, the driver route choice behavior under navigation guidance is divided into two levels, which is the appropriate model. And through the joint estimation of the parameters, we can see the environmental attributes significantly and strong impact to driver's compliance. And also by reconstructing the upper level decisions, additional utility from the navigation, we can see the storm. It found that dependency spikes during the rainstorm days. So there are some observation from the first part. So the second part of the study is about the prediction of the road network, the congestion status. So for this one, we know normally when we make the traffic status prediction is in the more of the normal situation. For the abnormal speed variation is much more challenging, particularly in the sudden events like severe weather and so on. So this is a challenging topic. And we do see some of the research gaps from the typical model. Stationary assumption is no longer applicable. And so we started to think about which model we have. So for this one, we start to use the end-to-end model to describe. And then we have two models to try. One is a neural control differential equation model, NCDE model, and the other one is a graph wavelet transform. And also we trying to see the graph Fourier model to see the difference and trying to compare. So here how we set up the NCDE model. And then for this, we can have NCDE not only for the temporal control, and also we have the graph control for spatial. So with that, we can see which part of the information has more of the model setup in this NCDE model. Here is showing the data we used for this. This is for, we use the data from March last year, 2023, and then we use the data from Beijing. We also see this is some incident from here. And here is showing the experimental setup. We trying to use some historical data to predict the future status for the traffic network. And here we use the MAE and IMSE to compare with historical average, support vector regression, LSTM and STGCN is all the model we compare. And here is showing the results from the NCDE model. And this is showing MAE of each model to the right. This is showing the graph. So basically, when we set up the NCDE, considering both the temporal and the spatial for the emergency events, we can have a good result from when we compare with the other model. Now, this is IMSE. And here is showing which part, either the temporal or the spatial, has more of the impact from the ablation study. We can see from here, both parts really necessary for this study. So both play a major role in the model. And then we're also trying to see in the accident scenario, which is more challenging. We can see this is this model NCDE really play a very good result when we compare with other ones. And here is showing the well, the normal situation, we also have this model also play well, but majorly, I still say in the emergency situation, this model particularly play very well when we compare with other models. So here is some observation from this part of the study. And with NCDE proposed, so it's capable of simulating complex dynamic change within the continuous time range. When we see the sudden change, this NCD is quite helpful. And also when we introduce the wavelength, the graph wavelength, it can also deal with the sudden change from the events. It's a very good result at the end. So this is the second part. And the third part with, as I said, with the first part, we can understand the driver, the route choice. And the second part, we can predict the future status of the network. And then we can do the group navigation. What is the group navigation? Here we say the user optimum routing this is a typical navigation do. Basically, give the based on the current information, and then we give the best route for each of the user. So this is based on each user. But there's a situation during the serial congestion, or there is a heavy rain, all the drivers, we give the suggestion for the other rule, maybe the detour rule. But for the detour rule, it seems all the drivers coming to this rule, and it became even more congested than before. So if we don't consider the group navigation, then we're going to see the back and forth congestion in the network. So this is not very good, particularly for the emergency situation. This is why we have the group navigation. And then current route choice behavior doesn't consider this emergency. This is why we consider this. And also, we consider the emergency vehicles also running during the network. So this is still the plan. It's ongoing. We haven't got a lot of results yet, but this is the plan we want to have. So basically, at the first hand, we want to do the system optimum from the a system optimum assignment, basically based on the equilibrium. We can know which is the best way to do the assignment for all the traffic, and then based on all the information, and then we understand how driver will make their choice, and then combining both information, we can make the group navigation. This is basically the robust optimization based on all the random information we have, also the randomness of in the driver choice model. So we can basically make the robust optimization and then make the route choice for all the groups, a few groups. So this is the plan for that part. So basically for now, what we did is based on all the mass navigation information, we found the driver's compliance rate is increased during the rainstorm, during the emergency situation. And the system level group navigation is the way. This is the way to go to consider such behavior in emergencies. And then our future plan is to develop the dynamic robust optimization for the group navigation, considering the equilibrium of the whole road network and considering different group of drivers. So with that, this is, as I said, this is ongoing results. And if you have interest of our group study, you can go to the website, THU Lead. This is our group. We have our paper there. Well, with that, it's very thankful to be here and to show people our ongoing results. So I would like to see if you have any questions or any suggestions for our projects. Thank you.
Thank you, Professor Mangley. This was a very, interesting, thought-provoking presentation. And most importantly, I was, amazed to see the level of data from the AMAP platform that you have access to. I mean, just the visualization of this data itself can bring so much of decision support, leave aside all the analytics and modeling that we can build on that to further, provide very efficient and data-driven support on traffic management in emergency situations. So for me, I think it was quite a delight to see that you have access to such rich and dynamic data, which opens up so much of possibilities in better traffic management, especially during emergency situation. And this your presentation was specifically about flooding and rerouting. This is situation in our Indian cities also. We are facing very badly, even in my city, Bangalore, where heavy rains, not so heavy rains also are just creating so much of uncertainty in the transport system and disruptions, and authorities are still grappling to find answers. But I think having access to such data could be extremely useful, and thanks to all the analytics and modeling that your team is doing. So with this initial remark, I can request all participants to please type your questions in Q&A tab that is available on the top menu, and type your questions, and I'll take them one by one. I think there's already one question that I can see. Other participants may also type their questions here in the meantime when I ask. So I'll take the questions for you, and you can answer, Professor Mangley.
Okay.
The first question is from Rohit here, and the question is for the speed prediction model among statistical machine learning and CNN methods, which you showed in your slides. Can you provide brief details on these methods and a brief comparison across them? Which one is better in what situation among these methods? That's what the question of Rohit is.
Yeah, thank you for the question. Actually, this is about the second part of our research. I conclude a little bit at the end. We basically introduced two part of the model. One is NCDE, the other one is wavelet transform. And we realized when we compare the different models, we realized the NCDE is better for the dynamic change for continuous time range. But for the wavelet transform, this is better for the sudden change situation. So basically, this when we see the emergency situation, the rain, the rainstorm, the heavy rains, so the wavelet transform is a better model for this. So this is compliant from our model results. Yeah.
Great. That's great. So we
Yeah.
have a clear answer on that. Thank you.
Right.
I'll take another question. This is from Aditya. Can you clarify how the aspects of dynamic conditions or environment are being considered in the route choice behavior? And further, he's asking if there is a scenario which is completely unpredictable, how will the route choice get affected?
Yeah, well, thank you for the question. And actually, well, first, what the first part of the question is what environmental factors we consider, basically. And as I said earlier, this, well, for the environmental part, which is a group A1, we have information, say, the weather. Okay, let me go to that slide. It's to the. Okay, it's here. Okay, basically showing here environmental factors, including the weather we have, and also it's also including the static part. It's about the flooding information we have, and also the incident information from the road. So basically that's environmental. It's outside information we can have from the data because the research is the data-driven research, so it's really based on what we have from the data. So the data we have, including the weather information, and also you have the incident, the traffic accident, or work zone, and so on. So those are all the information we can have. So based on that information, we set up the model. But you ask if there are some other situation which is very
Which is
abnormal.
unpredictable. Yeah.
It's unpredictable. Yeah, well, that's true. But if, well, the thing is, we have a data-driven study. We set up the model. If we can have that information, saying even it's a very low probability, but we can still set up the model with that, as long as we have the data. So as long as we have the information, so we can set up the decision model with that part, even it's a low probability. But if we don't have that data, then We cannot. So basically, this is the data-driven research what we can do.
Great. Um, and this data, the related to environment and other dynamic conditions, does it come in real time? No, no.
Well, for the model part, no. Yeah,
Okay.
we are now having the real-time data. Basically, we're having the historical data. This data we use is March to April, which is quite some rains happened during that days, and they all the historical data.
Okay.
We plan to use our model for in the future. We have the real-time information, uh, limited information from the real-time. Say the weather, we can have, and then so basically the model is trained by the data offline using the historical data, but we
Okay.
want to use the model for the real-time input in the future. Yeah, that's a plan.
That's great. So the next question is, from Manisha, she's asking, can you explain a little bit about the upper level choice decisions in the model?
Yeah. Yeah, this is basically the upper level decision. Basically, the upper level decision is about the whole route, the whole path you're gonna choose. So basically, when you start to go from your origin, you make a plan. So this is the upper level. So the lower level is more of the step-by-step the dynamic decision. So this is about the upper level. For the upper level decision, when you select the routes, you have basically two group of parameters. To the right is A1 group about environmental factors. A2 group is about navigation related factors. So you can see either is a congested, quite congested on the route, or there's some flooding or accident. So that will be a factor when you choose which route you want to go. So this is the upper level decision model.
Okay, that's great. And yeah, that's great. Um, um, there's another question from Purnima Priya. Can similar research be done for railways application?
For what?
Applying applying in railways, the railway network, for railway network, say metro rail network or
Oh,
intercity rail network. Can we apply similar research for railways application?
I think yeah, it's quite doable. I think um, uh, for the neural network, right?
I mean, the way, for example, you have worked out this whole emergency scenarios for a road network or a road traffic network, can we do
Uh-huh.
it for, railway network operations? That's
The
what.
railway. Okay, I see.
Yeah. Yes.
Well, I would say the road network is more. I would say it's more challenging in a way because there's more of the randomness in the road network comparing with the railway network. And also on the roadway, there's each driver make their own decision on the road. But on the railway is more of the planning side, how we optimize the scheduling and so on. That part is more challenging. But with the scheduled rules, the driver cannot make change on the way. So I would say it's a quite different when we compare the road network with the rail. This is more fit for the road network, I would say.
Yeah. Yeah. And it will also be dependent on what data and
Yeah,
dynamic data you can get for about the railway operations.
yeah,
Uh,
exactly. Yeah.
So the next question is, how are the flooding levels integrated into the study? Is there a level of flood depth being considered while, doing the modeling and scenario analysis?
What's that? I didn't get that question.
Sorry, I'll repeat what the question is. How are the flood levels, the level of flood on the
Uh-huh.
network, is integrated into the study? And is there a level of the flood depth that you have considered in your model?
Well, yeah, that's a good question. Well, for this study, I can see some of the results showing about the flooding, but the thing is, this is maybe still a limitation for our current research. We don't have very much flooding on the road for those the data. Very rare, very limited. We don't have very significant flooding in this. This is the center of Canton, city of Guangzhou. There are some heavy rain, but flooding. Well, the watering system is very well running, so it's a very limited time and very limited area. It has some flooding. But maybe if we can have the data for some mountainous area, we can have more of the different level of the flooding. But for
So
now,
what
the
about
model, we don't have that much. Yeah.
what about in Beijing? Generally, when there are heavy rains or weather situation, do you do the city encounter some roads being partially flooded or so on, or there also the drainage is quite efficient?
Well, right now it's quite efficient. There is a few years
Okay.
back, say
Uh,
maybe 7 or 8 years back, there was
mhm.
the super heavy rain in Beijing, and the system was crashed down at the time. And there's even one fatal accident. One guy driving a car going into the water and cannot come out for some reason. And so that really ring the bell. And
Mhm.
after that, the city really put a huge amount of
Okay.
money to improve.
Okay.
So right now, it's quite efficient for the system right now, I would say.
So which also means that any damage to the road surface quality due to rainwaters may also not be much. For example, the occurrence of potholes or other kind of road defects or cracks due to rainwater, they may also not be a major issue or a problem since the rain water is draining off quickly.
Well, I would say for Beijing is a very north in China, so we don't really see that much of rain, that heavy of the rain in Beijing. But in the southern part, well, I would say nowadays there are more and more severe hurricane. Some
Okay.
time period there are, I would say even the system is very efficient, but the rain is even more, is a bit stronger. So in the southern part of China, there are some cities during some time there are flooding area. But for
Okay.
our data for now, we don't have that yet.
Okay, okay.
Yeah.
So the next question is, has the accident data used in these scenarios been collected during these emergencies?
Yeah, we do have the, as I said, there we do have the accident information, and while one from the user report, some user will report we see, and also we have the traffic police information. So that's those all included in the modeling right now we have.
Okay, okay. So the question was that were these accident data happened during the situation of emergencies or weather conditions, or they were at some other time when the weather condition was not there?
Well, we don't really study whether it's more frequent of traffic accident during the rain.
Yeah.
But this is for this study, we basically understand if there are rain and also accident, and then the driver for how long he will decide to change the rules or not. So this is basically what the model is doing. So, but we from the data we do see with the heavier of the rain, there are more of the accidents for sure. Because while it's abnormal congestions and people are getting mad on what's going on, waiting for a long time. So there are quite some abnormal behaviors on the road. And there are some accidents, more actually than the normal situation. Yeah.
Okay. Some more questions. There's one participant who is interested to know where can we find the publications regarding the study that you presented. Are there any? And are the data and codes available in open source, or can it be available upon request?
Well, our paper is under review, not yet published yet. For the data, for now, it cannot be open yet. Because the reason, this is a very good data set. The reason why they would like to open is because a national project, research project with funding. So they want to put the data, and also this is for emergency. So this is so AMAP would like to use the data for research within the group. But whether they can open some of the sampling data, we are still talking with them. Particularly with the paper we publish, now the journal would like us to open some of the data, so we are still working
Mhm.
with AMAP on that. But there are some process to do that.
Yeah, yeah.
Mm.
There's another question, how the present data-driven model based on historical data can be modified for real-time data?
Well, this is a model trained using the historical data. But in the historical data, once we set up the the root choice model, we can use, basically this is the purpose, we can use in the real time with the real information. Say, if we set up a model for one particular driver, giving all the parameters, and then in the real situation, when we input the rain situation, the environmental situation, and also the congestion and the road network, based on the data, the model, we can see, or we can basically predict what the driver will make the decision. And then with that, at the end we're gonna do the group navigation. That's a purpose. So because for the group navigation, we need to know if we give a route suggested to the one driver, we should know whether he's gonna comply or not. So otherwise, the group navigation is pointless, right? So this is why we have the choice model at the beginning. We can estimate, given the situation, how he or she gonna make the decision, and then this is all in the real time, with all the real time input, and then we can use that for the group navigation, which is also in the real time. That's a purpose for the project.
Yeah. Um, um, Also, this whole scenario about drivers being given the route choice, the route options based
Mhm,
on the model results, and
mhm,
what is the idea? I mean, in a real situation, will this suggestions be transmitted through a app or on the dashboard of the car, or what is that way?
mhm, mhm.
We think these information would be relayed and drivers can then take a decision.
Right. Basically, for the group navigation, it's like given all the environmental situation, the information for now, and then we have a few routes to select. And then once we do the robot optimization, we can decide for how many drivers and who we're going to give
Mhm.
this route for suggestions. So that route will going through a map or even the onboard dash to give the suggestion. And for the other group, we're going to give another suggestions. So with that, we can have a better system optimal situation with group navigation. This is what the purpose is.
Okay. So in your choice modeling, as you were mentioning that,
Mhm.
route choice models have
Yeah.
very seldom, incorporated emergency, scenarios. So how have you actually modified or model the route choice modeling? I mean, what are those specific parameters that basically takes into account the emergency situation? If you can explain that again.
Yeah, this is basically what we have for the basically two levels. For each level, I have saying, okay, let me. This is in the real case we have. This is for the upper level decision one. The driver make the choice for the route at the beginning. So we have all the factors here. For A1 group is about environmental factors, congestion, weather, accident, and so on. The other one is a navigation related factor, is the detour distance and so on. So this is for the upper level decision attributes, and this is for the lower level attributes for group B1 and B2. B1 is about the static, the network, the geometry basically. B2 is about dynamic network situation on the road, what you see, what's around these congestions and so on. So what decision for the lower level you're gonna make. So this is all the attributes for the study we have.
Great, great. This
Yeah.
is quite interesting. Um, um, if there are any other more questions that the participants may have, you may please ask now before we close this session. Of course, this is a very interesting presentation and quite a lot of possibility. While we may wait for a minute, there are more questions. What other research you are planning to do with this data set with respect to emergency or evacuation? And what plans do you have for utilizing these data and do more research? If you can brief us.
Well, this is for current plan. We just started this project this year, so
Mhm.
this is a great data set. The
Yes.
AMAP share for particularly for this project purpose. And
Yeah.
for now, we think there are enough things to do for now. We
I know.
haven't
I
really
know.
really think about the next step. But with that, I think if the AMAP can see the potential of using the data for the research and also for the future applications, I think they can use this data to do a lot more things.
Yes, yes,
Yeah,
yes. I'm sure,
even
there
yeah,
are so many interesting possibilities to utilize
right,
this data
right.
in future. It's quite exciting. I think that's where really the future of research and analytics could bring value
Yeah,
with such data sets. That's great.
exactly.
I don't think we have any more questions now.
Okay.
But looking at the all the curious questions and discussions, one can really understand this was a very interesting session for all of us. For me also, there's great learning, I'm sure. With this few words, and thanks again for taking time to present this fifth webinar on a very interesting and challenging topic. Professor Mangley, thanks again from all of us. And to the participants, of course, please do look for the next webinar roughly after 2 months from now. We'll again come back with another very good speaker. Um, and yes, please keep in mind the symposium next year, June. The call for paper is still open. If you are willing and interested, please do submit. Now, with that, these words, again, thanks a lot to you, Professor Mangley, for this excellent and very insightful presentation. Thank you.
Thank you, Ashish. It's my honor.
Thank you. Thank you. Take care. Bye bye. We
Bye
can
bye.
close the session now.
Okay.
Hemanthini, you can close the session. Thank you.